Hello guys, this is the question. By using Hamming method we need to solve this problem. The given question is that they have given message bit value or data bit value. The message bit or data bit is the 101101 and they told us to find out by using the odd parity mechanism, right? So from here what we have to understand is in the given question they have given data would or message bit value. So now what we have to do is, it is the transmitter side question, we need to perform the encoding operation. So encoding means we need to attach extra bits to the original message bit, right? So those extra attached bit we called as the parity bit values, right? Now question is that we need to find out how many parity bits are required, right? So we clearly explained in previous lecture, right, how to find out the parity bits, right, what is the requirement of the parity bits, everything we have explained. If you didn't watch that previous video, please watch that previous video also, right? So there is a given question, message bits they have given, we need to find out the parity bit value, right? Now how to find out the parity bit value? To find out the parity bit value, the formula is 2 power p greater than or equal to m plus p plus 1, right? So how to find out the parity value? We know message bit value as per the given question is this one. This is a message bit value as per the given question, but we need to find out the p value which we don't know, right? So for example, so in order to find out, so what we are doing is we are going to perform something called as the trial and error method, right? We are going to perform the trial and error method. So trial and error method means initially I don't know what is the p value. So for example, here I am considering the p equal to 1. Just substitute in this formula. What is the answer? You will be getting 2 power p means 2 power 1 greater than or equal to, what is the number of message bit value we have? Just count the total number of bits, 1 2 3 4 5 6. So m value equal to 6. It is always fixed as per the given question. So m equal to 6 plus what is the p value we consider? 1 plus 1. Now if this condition is satisfied or not? No, this condition is not satisfied, right? 2 is not greater than or equal to 8. So it means that we should not consider the p equal to 1. So like that we have to produce the p value once if this condition is satisfied, greater than or equal to condition satisfied, that is nothing but your p value. In this case, what is the p value? Suppose for example you consider p equal to 4, then substitute 2 power 4 greater than or equal to, m value is constant, 6 plus 1, right? So something we need to apply this value, right? So 2 power 4 means the value is 16, right? So 16 is greater than or equal to 11. So what do you mean by this? This condition is satisfied. So number of parity bits value, we need to consider the 4 parity bit value, right? We need to consider the 4 parity bit value, right? First step is that we need to identify how many parity bits are required, right? As per the given question, we have 6 message bit, 4 parity bit. Now what is the total length of the transmitter code word? It is the combination of the message bit plus parity bits. Now total length is the 6 plus 4, nothing but the 10 bit value, right? So here what we are going to do is just we are writing the decimal representation. Like see, I have 1 2 3 4 5 6 7 8 9 10. First step we are identifying the number of parity bits required, then we are going to find out the what is the total length of the transmitter code, then we are writing the 1 2 3 4 5 6 7 8 9 10. Once it is done, so what is the maximum number here? 10, right? What is the binary number for 10? 1 0 1 0 is the 10. So just write the binary representation. Here we are considering the 4 bit, right? Here also we will try to convert the everything in terms of the 4 bit value, right? And after identifying the length of the transmitter code word, just we are writing the binary representation, right? Once it is done, the next step is that we need to find out the identification of the location of the message bit as well as the parity bit, right? So what do you mean by this? We have 10 bits, we don't know what is the exact place where to we have to place the message bit value as well as the parity bit value. If you know, then problem will be solved, right? So there is no mechanism to find out what is the corresponding location of the message bit, but we have the way to find out what is the location, means in which location we have to insert the parity bits value. Simple thing is that if we can able to identify the location of the parity bit, then if it is not parity bit, remaining all will be the message bit, right? This simple logic we are using, right? So to find out or to locate the parity bits, we have the binary format, right? R power 0, R power 1, R power 2, R power 3, something, right? For integer part direction, right? So binary means 2, 1, 2, 4, 8. So this is the location where we need to insert the parity bit value. So see that for first location, this is the first location we need to insert P1. Second location, it is nothing but second location P2. Then fourth location, nothing but P3. Then eighth location, nothing but the P4, right? So here we are placing like this direction. So if this is parity bit value, this is parity bit value, this is parity bit value, this is parity bit value. So out of 10 bits, we know that 4 locations are the parity bit. The remaining 6 locations are the message bit value. Means this is like this we are going to write. So here it is empty place, right? P1, P1 after P1, P2, this is empty place, right? So here we need to write the M1. The empty location M2, M3, M4. After P4 we have the M5, M6, right? So we have identified the where we need to place the parity bits as well as the message bit also. Once it is completed, now how many parity bits we need to find out? So for example, as per the given question, they have given the message bit word is 101101. So see that the message bit is 101101 is the message bit value. Let us assume that initially you don't know this P1 value, P2 value, P3 value, P4 value, right? Initially we don't know P1 value, P2 value, P3 value. So if you want to find out the first P1, right, initially we don't know what is the P1 value, right? As we discussed in the yesterday's class, so P1 always should be compared with the, meaning is that all parity bits should compare with the all message bits, but we should not compare with the parity bit value, right? It means P1 should be compared with M1, M2, M3, M4, M5, M6, right? So how to find out M1, M2, M4, M5, M6 means, see that in which location P1 we have the 1, this LSB bit value equal to 1. It should be compared with the message bit 1, right? So check whether this LSB bit is matches with the LSB bit of the first message bit value. See, LSB of the message bit also 1. If both are matching, you just write down the value of that particular message bit. If not matching, no need to write the value. Just skip out, then go for the next combination. Now what is the value for M1 we got? The LSB position is matching, so here we need to write 1. Next again compare P1 with the message bit 2. Do we have LSB bit 1, right? So here see that we have the LSB bit value equal to 1. You don't need to bother about remaining 3 bit value, right? Just only compare with the LSB bit value is matching or not. Yes, it is matching. So what is that corresponding message bit value? The message bit value is 0, right? The corresponding message bit value is 0. Like that we need to find out for, right? 1 0 is completed. Now compare with P1 with M3. It is matching, not matching, right? Here it is 0, here it is 1. So we should not consider this value, it means. That's it. Now go for compare P1 with the M4. Here it is matching. What is that value? 1 is that value. This value 1 is that value, right? So now compare P1 with the M5. Yes, it is matching. What is that value? That value is 0. We are writing here, right? So compare with the M6. Compare with P1 with the M6. It is not matching, so skip the value, right? So after finding the P1 value, this is the combination we got. What is the combination we got is this combination we got, right? So initially we don't know P1 value, right? Then we got after comparing 1 0 1 0. Now see that as per the given question we need to implement the odd parity mechanism. Just count the total number of ones. How many total number of ones? 2 ones are there. Now it is even number or odd number? It is even number. So how to make it as the odd number? Just add the one more 1, so that here it will become the odd parity, right? So what is the answer for this one? 1. So like that we need to find out the answer for P2, P3, P4, right? For example, if you suppose you are checking for the P2, initially we are considering this is the unknown value. P2 should be compared with the M1, but what is the location we have the P2 here? At the second location. It should be compared with the message bit second location. Yes, both are matching, right? Matching means what is that value? We need to write the value equal to 1. Same like this. We need to write the value. Again P2 should be compared with the M2, right? Here second bit is matching. No, right? We need to discard this value, means we should not write this. Again compare P2 with M3. Second bit is matching, right? No need to Consider about the remaining bit. Only just check the parity bit. We have some position 1. In the same position we have the message bit 1 or not. If it is 1, write that corresponding M value. If not, just neglect it, then go for checking of the next message bit value. So like that we need to find out, right? So once it is completed, so initially we don't know, right, what is the p value, p1 value, p2 value, p3 value, right? Now if you observe, initially we don't know what is the p1 value, this value we don't know, this value we don't know, then one more is p3 we don't know, p4 we don't know. Only as per the given question we know that this is 1 0, this value 1 0 double 1 0 1. So here these unknown values we need to find out. For that we are finding p1, p2, p3, p4. After finding these value, right, we are placing. What is the p1 value we got? 1. P2 value 1, p3 value 1, p4 value 0. Now see that transmitted code word is the combination of message bit value. These are the parity bit value. So this is the total transmitted code word. This information we are going to send through the channel. At the receiver we are going to identify whether the information received by this one is correct or wrong. In which condition? Even if you don't know what is the information transmitted by the transmitter also we need to find out. For that reason we are learning the Hamming method, right? I hope you understand. Thank you. In next class we will try to complete the problem solving by using of the error detection correction code by using the Hamming method for receiver case of the problem. So in the transmitter part here we are not going to find out whether it is error or error free. As I discussed earlier, in the receiver section only we are going to identify whether the received information is correct or not. In transmitter side what exactly we are doing means just we are performing the encoding, appending the extra bits, nothing but the parity bits. That's only we have to do. For sending the information from transmitter to receiver, we need to identify whether it is error or error free. Thank you guys.